Hello, Algebra Honors. This is our Unit 7, Day 7 set of notes. So Unit 7 is polynomials. We are still factoring our polynomials, and we're going to talk about special cases today. So first, I want to talk about trinomials that we can call perfect square trinomials. So perfect square trinomials follow certain rules. And an example one is this x squared plus 6x plus 9. You'll notice with a perfect square trinomial that there are going to be some perfect squares, and it's a trinomial, of course. So your first term is going to be a perfect square, like x squared. Your last term is going to be a perfect square, like 9. Your middle term is always going to be the square root of the first term times the square root of the last term doubled. Okay, so x times 3 is 3x. 3x doubled is 6x. So your center term is always going to be double the square root of the first times the square root of the last. All right, so we're going to look for some more specific ideas here as well. If I am adding my middle term, then I'm going to say that I have x, the square root of the first term, plus 3, the square root of the last term. If I'm subtracting that middle term, my binomial is going to be a difference instead of a sum. Okay, so again, notice that in this trinomial, the first and last terms are both perfect squares, and the middle term is twice the product of the square root of the first and the square root of the last. Okay, when you factor x squared plus 6x plus 9, if I were to factor it with our x puzzle, I know I need two numbers that multiply to give me 9, but they have to add to give me 6. Well, those two numbers are 3 and 3. So I know that I could say that I have x plus 3 times x plus 3, right? That's just factoring it out manually, I guess. But once I start to notice these patterns, I know x plus 3 times x plus 3 is actually x plus 3 squared. And so if I notice those patterns and confirm that I have a perfect square trinomial, I can go straight to writing out that binomial squared. All right, so we're going to ask ourselves some questions when we're solving. When we're factoring trinomials, we're going to say to ourselves, is the first term a perfect square? Is the last term a perfect square? If yes, it might be a perfect square trinomial. Take the square roots of each and then multiply them and double them. So square root of x, square root of 64 is 8. 8x doubled is 16x. So if you can say that that's true, you have a perfect square trinomial, and you can very quickly write out the factors, right? I'm going to take the square root of my first term, the square root of my last term. Because my middle term is positive, I'm adding it. I know I'm going to add those two binomials, and I square that binomial. Okay, so let's break this down. The questions you ask yourself, you say, is the first term a perfect square? X squared is a perfect square. Now my m and my n, we're going to just throw all kinds of variables at you. Generically, I can say anytime I have a binomial that's m plus n, and I square it, I know it's going to be a perfect square trinomial that looks like this. First term squared plus double the product of the two terms plus the last term squared. Okay, so that's just generic. So I'm going to say, is my first term a perfect square? Yes. So if that were m squared and I took the square root, m would just be x. Just bear with me with the variables. Is the last term a perfect square? It is 64. The square root of 64 is just 8. Okay, so you can see that I'm getting ready to put these back into the binomial, right? M squared was x squared. N squared was 64, so just n is going to be 8. And then x times 8 doubled is going to be 16x. Does the middle term equal 2 times m times n? Yes. 2 times x times 8 really is 16x. So, yes. All right. Let's see if this guy is going to be a perfect square trinomial. First term is a perfect square, yes. Last term is a perfect square, yes. And if I take the square root of x and the square root of 121, I have 11x, right? Doubled is 22x. So it is a perfect square trinomial. So I know that I can take the square root of the first term, and I can take the square root of the last term. I have a positive, or I'm adding my middle term, so I'm going to add here, and I square that binomial. Once more, was that first term a perfect square? Yes. the square root of x squared is just x, so my m value would be x. Was the last term a perfect square? It was. The square root of 121 would be 11. Does that middle term equal 2mn? It's 2 times x times 11, which is 22x, and so the answer was yes, it does equal 2mn. All right. One more time, 9x squared plus 30x plus 25. Well, this first term, 9x squared, it is a perfect square, right? 9 is a perfect square and x squared is a perfect square. So I know my first term, m, is the square root of 9x squared. It's 3x. My last term, 25, is, the square root of 25 is 5. Okay, so n is 5. Does the middle term equal 2mn? Well, 2 times m times n is 6 times 5 is 30, 30x. Is that what I have? Yeah, yes. So I know it's a perfect square trinomial. I can write it as the square root of my first term, the square root of my last term. My center term is being added, so I'm going to add inside there. Okay? You can always multiply these out again, just to make sure that you believe yourself. Don't forget that you cannot distribute that outer 2 across addition. You're not allowed to do that with exponents. So you would have to check this by saying 3x plus 5 times 3x plus 5. So if you want to check your work, this is where 2mn comes in, right? First 2 multiplied is going to be 3x squared. And then if I have outer, it's 15x. Sorry. Outer is 15x, inner is 15x, so I double it, right? It's 30x. And then my last 2 terms multiplied would be 25. So this is just me checking my work up here, but don't forget, you can't just square each term. Okay, so let's take a look. I have x squared plus 18x plus 81. Is it a perfect square trinomial? X squared is a perfect square, 81 is a perfect square. Is my middle term 2 times the square root of the first times the square root of the last? 2 times 9x is 18x. So yes, I know it's a perfect square trinomial. So I take the square root of my first term and the square root of my last term. I'm going to square all that. And because I'm adding in my middle term, I'm going to add. That's an x, even though it doesn't look like it. Okay. X squared minus 24x plus 144. Well, the first term is a perfect square and the last term is a perfect square. So I need to know, is my middle term the square root of the first times the square root of the last doubled? X times 12 doubled is 24. So yes, but the only thing to notice here is we're subtracting. So square root of the first term is x, square root of the last term is 12. Since I'm subtracting that middle term, I want to say x minus 12 squared. All right, x squared minus 12x plus 36. The first term is x, the last term is 6, and 6x doubled is 12, so I know that I have a, it's 12x, so I know I have a perfect square trinomial. I'm subtracting that middle term, so I need to make sure I'm subtracting and show that I am squaring that binomial. All right. You know, you always want to check for a greatest common factor first before you do any factoring. Just keep that in mind. X squared plus 4x plus 4. I'm going to assume it's a perfect square trinomial, but we're going to find out. My square root of x is x. I'm sorry, square root of x squared is x. Square root of 4 is 2. If I multiply those together and double it, 2x times 2 is 4x. It really is a perfect square trinomial. I'm adding that middle term up here, and so I know I get to add inside my binomial. Perfect square, perfect square. Square root is 4x, square root is 3. 4x times 3 is 12x. 12x doubled is 24x. Here it is. Square root of 16x squared is 4x. Square root of 9 is 3. My middle term is being added, so I'm going to add those in my binomial. One more time. 4y times 11 is 44y. Doubled is 88. So I'm going to have 4y, and I'm going to have 11. And since I'm subtracting in the middle, I know I'm subtracting inside my binomial. Okay. So difference of squares is a different way that we can look at things. We've been looking at, just to remind you, perfect square trinomials. in those perfect square trinomials, this is always true. Your first term is a perfect square, your last term is a perfect square. And when you take the square roots of the first and last, multiply them together and double them, you're going to get your center term, either adding or subtracting. Okay, so the next example of a special case is going to be difference of squares. You know difference means subtraction, right? So if I'm looking at difference of squares, I'm subtracting one perfect square from another. All right, so if your binomial has this form, m squared minus n squared, that is a square, perfect square, minus another perfect square. It is a difference of squares. You can break it up into the square root of the first plus the square root of the last, times the square root of the first minus the square root of the last. Okay, let me do this math and show you that that's true. M times m is m squared. M times negative n is negative mn. This is hard to say. Inside I have n times m, but I'm going to write it as mn. And then last, n times negative n is negative n squared. See how my inside and outside terms, or outer and inside terms, they cancel out, right? The only thing I'm left with is m squared minus n squared. That is always going to happen if you have a difference of squares. So here I have x squared minus 16, so I'm starting with that binomial. Since I have a perfect square minus a perfect square, I can rewrite it. It's going to be x plus 4 times x minus 4. That's going to be the pair of binomials. If I wanted to write x squared plus 0 x minus 16, now I can see a, b, and c, right? If I want to think of this as an x puzzle, I need two numbers that multiply to give me a times c, so that's negative 16, but they have to add up to be 0. The way I do that is a positive 4 and a negative 4, right? 4 times negative 4 is negative 16, and 4 plus negative 4 is 0. All right, so let's take a look. We're going to factor these polynomials down here. So if I have just two terms, if it's just a binomial, I'm going to look. Is it a perfect square minus a perfect square? This is x squared minus 64. So I know that I'm going to take the square root of the first and the square root of the last. I'm going to have x plus 8 times x minus 8. This way, when I check my work, I have x squared minus 8x plus 8x minus 64. I cancel out those inner terms, right? X times x is x squared. Outer is negative 8x, inner is positive 8x, and last is negative 64. Every single time, if you've done it right, those middle terms cancel. X squared minus 144, I'm going to write it as x plus 12 times x minus 12. If you wrote it as x minus 12 times x plus 12, that is true also. Okay, x squared minus 25, perfect square, perfect square. This is a difference of squares. So realize that this does work. I can factor that out. But if I have x squared plus 25, right there, that is not a difference of squares. That's a sum of squares, right? You're adding those. If you wanted to figure that out, you know that means x squared plus 0x plus 25. If you do your little factor x puzzle, you need two numbers that multiply to give you 25, but they add up to 0. You can't do it, right? That doesn't happen. So you cannot factor out x squared plus 25. That just stays x squared plus 25. Just kind of keep that in mind, okay? It's got to be the difference of squares. All right, so x squared minus 25. I have a perfect square, I have a perfect square. This is a difference of squares, so I'm going to write it as x plus 5 times x minus 5. Perfect square, this is a difference of squares, x plus 9 times x minus 9. Perfect square, if you do this enough times, it'll be forced into your mind. So you can try the rest of these, but be careful when you get down to like number 7, 8, and 9, okay? So maybe just try number 6 and then come back. Okay, this is a perfect square and this is a perfect square. I'm going to take the square root, that's 3x, and the square root is 6. So I have 3x plus 6 times 3x minus 6. Okay, so far so good. When we get into higher exponents, x to the fourth minus 81. Well, x to the fourth is a perfect square. It's an even numbered exponent, right? The square root of x to the fourth is x squared. The square root of 81 is 9. So I have x squared plus 9 times x squared minus 9, right? Well, look closely. X squared minus 9 is a difference of squares. So I'm not done, right? So on a quiz or a test, you're not going to get full credit because you're not done. X squared plus 9 is a sum of squares, so I can't do anything more with that. That's going to stay. But x squared minus 9, difference of squares. It is x plus 3 times x minus 3. Did you catch that? All right, so try number 8 and try number 9, knowing what you now know. Okay, I'm going to try number 8. The square root of 25x squared is 5x. The square root of 64y squared is 8y. So I'm going to say 5x plus 8y times 5x minus 8y. No perfect squares in there anymore. I can always check it. 5x times 5x is 25x squared. Outer and inner cancel, and last is going to be negative 64y squared. Okay, careful, careful on number 9. The square root of x to the fourth is x squared. The square root of 1 is 1, so I'm going to say x squared plus 1 times x squared minus 1. But wait, what do you see? You see two perfect squares, and you see a difference. So x squared plus 1 stays, but I'm going to break up x squared minus 1, so that is x plus 1 times x minus 1. Okay, so you can find generalizations. You can always do the factorization using your X puzzles also, or your other methods, finding factors that multiply to be AC that add to be B. But sometimes it's quick and helpful to just start to notice those patterns. So we kind of have a nice flow chart for you to walk through factoring polynomials. Okay, so First, please look for a greatest common factor. And if you have factored something out and you're checking, which you should always do, if you're checking to make sure that you did it right by multiplying stuff back together, if it's just not working and you are convinced that you did everything right with your factoring, double check and make sure that there wasn't a common factor early on, because oftentimes that's going to leave you, if you forget to take out the greatest common factor, you'll be really close with your answers, but it's just not going to be quite right. Okay, so we have 3 special cases rules right here, just to remind you. This is a perfect squared trinomial where we have addition. This is a perfect squared trinomial where we have subtraction. And this right here, this is a difference of squares. So we would break it up to those binomials. If you cannot factor it, you're just going to write prime. All right, first look for a greatest common factor. Then, do you have 2 terms? If so, is it a difference of squares? Because if it is, you can break it up. Okay. If it had 3 terms, take a look at it. Can you find those factors of A times C that add up to be B? You can factor by grouping, or if you've learned the box method already, you can factor by box method. Okay. Or did you notice that it happens to be a perfect squared trinomial? If so, you don't even really have to factor because you know it's going to follow these rules over here of special cases. Right? If you have 4 terms, probably your best bet is to factor by grouping. And here, it could be 4 terms where the 2 center terms could actually be combined, but maybe it's already set up for you to factor by grouping, or you might have 4 terms that can't be combined. Okay. All right. Let's take a look. And this is mixed practice, so you probably can maybe watch along with a couple of the problems, but certainly pause the video and try some on your own and then come back and check your work. All right, x squared minus 16x plus 64. It's a trinomial. I have a perfect square in the front and a perfect square at the end. So is my middle term 2 times the square root of the first times the square root of the last? 2 times x times 8 is 16x. So I know that it's a perfect square trinomial. Square root of the first guy is x, square root of the last guy is 8. Because I'm subtracting that middle term, I'm going to say I need x minus 8 squared. X squared plus 13, x plus 7, no greatest common factor to pull out. I need to find two numbers that multiply to give me 7, right? 1 times 7, but they add to give me 13. Well, that can't happen, right? My options are 7 times 1 is 7, and 7 plus 1 is 8. So nope, so that's just prime. Okay, 3x squared minus 60x plus 300. Is there a greatest common factor? Always look for a greatest common factor when your leading coefficient is not 1. I can take 3 out of everything here, so I'm going to say 3 times x squared minus 20x plus 100. All right, so here's a time that you might want to start writing your answer up here. You are probably going to break that up into two binomials here. You just don't want to forget that 3, right? It is a part of the answer, so you have to be careful not to lose it. Okay, so I look at this and I have a perfect square here and I have a perfect square there. Well, square root of x squared is x, square root of 100 is 10, 10x doubled is 20x. So I know that I can break just the trinomial into x minus 10 squared, right? Square root of the first, square root of the last. Since it's subtraction in the middle, it's minus. I have to make sure I also bring down that 3. Don't lose it, okay? So I didn't end up using that skeleton. I could have, right? Because it's 3 times x minus 10 times x minus 10. I just really don't want to lose that factor that I've pulled out. Don't lose it. Okay. X squared plus 10x plus 25. Square root of x squared is x. Square root of 25 is 5. 5x doubled is 10x. This one's really straightforward. 2x squared minus 16x plus 128. The first thing I'm going to do is see if I can divide something out, and I can. 2 times x squared minus 8x plus 64. And so I see a perfect square and a perfect square. Okay, perfect square, perfect square. Square root of x squared is x. Square root of 64 is 8. 8x doubled is not negative 8x. So I am going to think about what could my answers be. Okay, so I'm going to write my skeleton up here so I don't lose my 2. Now I am just factoring that, x squared minus 8x plus 64. I need two numbers that multiply to give me 64, right? 1 times 64, but they're going to add up to negative 8. So I have 64 can be, let's see, it can be 2 times 32, right? But that together is too high. 4 goes into 6 one time, 4 times 16, 16 minus, or no, 20, nope, that's not it. The only other way I know to get 8, or 64 is 8 times 8. So it looks like there's no way for me to factor out that trinomial. The trinomial is prime. So I'm not finding any binomials, but that means this is my final answer because I was able to pull out just a single greatest common factor. Okay, x squared plus 17x minus 18. I want to know two numbers that multiply to give me negative 18, but I add them together and they give me 17. So that is going to be positive 18 times negative 1, right? 18 times negative 1 is negative 18. 18 minus 1 is 17. Since my leading coefficient is just 1, I can just drop my magic numbers from my x puzzle into those binomials. I know it has to be x in the beginning because x times x is x squared, and I'm going to drop in plus 18 and minus 1. Okay, x squared minus 121. Well, it's a binomial, and I notice that I have perfect squares, and that is a difference. I'm going to take the square root of the first term and the square root of the second term. X plus 11 times x minus 11. I need to do something to cancel out those middle terms. So let's just double check. X times x is x squared. Outer is negative 11x, and inner is positive 11x, and last is negative 121. Those cancel, and so I get back to x squared minus 121, so that worked. Okay, this is my answer. X squared minus 7x minus 30. No perfect squares at all here, except for x squared is a perfect square. I need two numbers that multiply to give me negative 30, but they add together to give me negative 7. I'm thinking it's negative 10 and 3. Let's see. Negative 10 times 3 is negative 30. Negative 10 plus 3 is negative 7. So here we go. X minus 10 times x plus 3. You know, if you wrote x plus 3 times x minus 10, you would be correct also. Okay. 4x squared minus 28x plus 49, perfect square, perfect square. 2x times 7 is 14x. 14x doubled is 28x. I have a perfect square trinomial. I'm going to take the square root of 4x squared, and I get 2x. Square root of 49 is 7. Okay, and since my middle term is negative, I'm going to put minus in there. You can always double check if you need to, but remember, if you're going to double check, you have to write it out and actually do the math. 2x times 2x is 4x squared. Outer is negative 14x and inner is negative 14x, so that's minus 28x. And last is 49. Here's the answer. All right, so that was one page. If you haven't been pausing to make sure you did it on your own, please do. It's so much more effective to practice doing these on your own and then make sure you're right. X squared plus 64, perfect square, perfect square. This is not a difference though, this is addition. And so there's no way for me to get rid of those middle terms, and so I'm just gonna say that doesn't change. It's x squared plus 64 or prime. Okay, can't do anything to that. X squared minus 10x, well that's only a binomial. I'm missing my constant term, or my constant term is 0. So it looks like I could pull an x out of each of those. 25x squared minus 169. This is a difference of squares. So I'm going to write 5x plus 13 times 5x minus 13. Okay. 2x squared plus 12x minus 32. I notice that they're all even. I'll pull out that 2. X squared plus 6x minus 16. So now my answer is going to be 2 times, probably, 2 binomials. So I'm just going to factor out that x squared plus 6x minus 16. I need two numbers that multiply to give me negative 16, but they add up to be 6. And 4 times 4 is 16. 8 times 2 is 16. Oh, that's it. Okay, so I'm going to say 8 times negative 2 gives me negative 16. 8 minus 2 is 6. Since my leading coefficient right now is just a 1, I can say x plus 8 times x minus 2. If you want to check your work once you've pulled out a greatest common factor, please multiply those binomials together first and then multiply everything by 2. Perfect square, perfect square. I'm going to say that's 3x and that's 5. So 3 times 5 is 15, doubled is 30. It's a perfect square trinomial, and so my middle term is subtraction, and so I'm going to have subtraction in my binomial. X squared minus 2x minus 63. I need two numbers that multiply to give me negative 63, but add to give me negative 2. How about negative 9 and 7? So I have x minus 9 times x plus 7. Okay. X to the 4th minus 16, that is a difference of squares. Let's break it up. Square root of x to the 4th is x squared. So I'm going to say x squared plus 4 times x squared minus 4. And I would move on, except for I know better, right? Once I start getting into higher exponents, I can expect that there might be little tricks in here, okay? X squared plus 4 I can't do anything with, that's done. But x squared minus 4 is again a difference of squares. So I'm going to break that into x plus 2 times x minus 2. All of that. You have to factor all the way down or you will definitely not get full credit. Okay? While this is true, it's like telling me 2/4 instead of 1/2. All right. 4x squared minus 16x plus 16. I'm going to pull a 4 out. Always look for your greatest common factor. I have x squared minus 4x plus 4. Now I have a perfect square and a perfect square. So I bet this is a perfect square trinomial. X times the square root of 4, which is 2. 2x doubled is 4x. It is a perfect square trinomial. Keep that 4, don't lose it. I'm going to say that this is x minus 2 squared. Now, if you had to do a problem like this to check your work, that exponent trumps everything else here, so you're going to square that first and then multiply everything times 4. All right, x squared plus 4xy minus 12y squared. Oof. So once you have two variables, sometimes it's easier to just factor by grouping. So x squared plus 4xy minus 12y squared. If this was just numbers, I would have some coefficient here, coefficient times x, and then I have just a number. But I have the y going on also, so I'm going to imagine that my coefficient of x squared is just 1. I'm going to imagine that if b was just in terms of x, the coefficient would be 4y. This is not the only way to do it. It's how I do it, though. Right? 4y times x. Up here, this would be like negative 2x, right? So I'm thinking, what am I multiplying times x? I'm multiplying 4y. And then my c is negative 12y squared. All right, I know it's a little bit weird to look at it like this. AC, of course, is going to be 1 times negative 12y squared. So this is the way I do it. If I look for AC, what multiplies to give me negative 12y squared, but adds to give me 4y. To get something to be y squared, I'm probably going to have something y times something y. Okay, we're going to assume that's what it is in a problem like this. So what do I multiply together to get negative 12, but it adds to be 4? I think it's going to be 6y times negative 2y. Do we buy that? 6y times negative 2y is negative 12y squared, and 6y minus 2y is 4y. So I think those are my magic numbers. So when I plug this in, my leading coefficient's 1, so I should be able to do two binomials, yeah? I'm going to say it's x plus 6y times x minus 2y. If you multiply it out, you get x squared minus 2xy plus 6xy, so that's plus 4xy, and then minus 12y squared. So there are different ways to look at that. Factoring by grouping is helpful too. Once you figure out you need 6y and negative 2y as your magic numbers, which means you have 6xy minus 2xy in the center. Okay, we're moving on though. You're building a square patio, and the area of that patio is 16x squared minus 72x plus 81. What is the length of one side? Well, you know area of a square is any side squared. So it wants me to take the square root of that, right? I can take the square root of something that's a perfect square. So let's see if it's a perfect square. 16x squared is a perfect square and 81 is a perfect square. I'm hoping, because I know how to take the square root of a perfect square. So let's see. If it's a perfect square, then 4x times 9 doubled. So 36 doubled is going to be 72. It is. Let's break it up. Okay, square root of 16x squared is 4x. Square root of 81 is 9. My middle term is negative or subtracting, and so I'm going to have subtraction inside my binomial. Okay, if the area equals all of that, then the area equals 4x minus 9 squared, right? And if area equals any side squared, then I can take the square root of each side, because that's fair. Square root undoes squared, square root undoes squared, so I know 4x minus 9 is my side length. All right, suppose the area of a square, again, is all of this. What is one side length? We're going to do that same thing, so try it yourself. Pause and try it yourself. All right, I know that area equals any side squared, and my area is 4x squared plus 20x plus 25. I see a perfect square and a perfect square. If I take the square roots, I'd get 2x and 5. 2x times 5 is 10x, doubled is 20x. This is 2x plus 5 squared. So my side squared is 2x plus 5 squared. I'm going to square root. I know any side here is going to be 2x plus 5. All right, so this guy, x to the fourth minus 17x squared plus 16, well, that has a lot going on, but I think I can do it. So let's kind of look at what we've got. It is a trinomial, right? And I know that if I wanted to think about it, a equals 1, b equals negative 17, c equals 16, and AC equals 16. So I'm looking for two numbers that multiply to give me 16, but they're going to add up to give me negative 17. And so that will be negative 16 times negative 1, right? Negative 16 times negative 1 is positive 16, and negative 16 plus negative 1 is negative 17. So let's see if we can do this by grouping, maybe. Okay, instead of saying negative 17x squared, I'm going to break it up into negative 16x squared minus 1x squared. So let's do it by grouping. I have x to the fourth. I'm going to say minus 16x squared minus x squared. That is the same thing as negative 17x squared, okay? And then plus 16. The only thing I changed was that center term. Now, can I pull stuff out? Well, if I pull x squared out of here, I have x squared times x squared minus 16, okay? And over here, I'm going to pull out just 1, so I have negative 1 times x squared minus 16. I'm pulling negative 1 out, and that has me with matching binomials. Negative 1, if I have negative x squared divided by negative 1, I'm left with positive x squared, and if I have 16 divided by negative 1, it's negative 16. So I have x squared minus 1 times x squared minus 16. So I feel like I'm done, except for I'm really not, because I know to look for patterns, right? This is a perfect square and a perfect square, and it's a difference. This is a perfect square and a perfect square and a difference. So I'm going to write this as x plus 1 times x minus 1, right? This guy is going to be x plus 4 times x minus 4. So keep looking for more ways to simplify everything. But we finally got to the end. So thank you so much for watching all of that. That was a lot of notes for Unit 7, Day 7, Factoring with Special Cases.